Hello and welcome back to Mr. Farina's algebra class. Today we are solving polynomials using the factoring method. Now, in order to do this, we use a property that we call the zero product property. Now, what this property basically says is if a times b equals 0, then two things must be true. A has to be equal to 0 because if a is 0, 0 times b would equal 0. And also, b must equal 0 because a times 0 would be 0. Well, using this zero product property in solving polynomial equations, once we're in factored form, our goal is to find the value of the variables that make this equation true, which means if I can make the left side of the equation equal 0, then I know 0 equals 0. Well, think about it here. If I can find the value of x that makes this equal 0, right? 0 times x minus 3 would be 0. And if I can find the value of x that makes this equal 0, right, x plus 4 times 0 would equal 0. And that's basically how we approach these. Now, a lot of us can see that x is going to be negative 4, and negative 4 plus 4 is 0. 0 times, negative 7 would be 0. But we want to get in the habit of, once we have it in factor form, to pull the factors out to the side, x plus 4, and set them equal to 0. Okay, now anytime I pull these factors and set them equal to 0, what happens is when I solve for x, okay, I end up getting the value of x that will make this equal to 0. And 0 times this is 0. So one of our solutions in this equation would be x equals negative 4. The next one, if I pull x minus 3 out and set it equal to 0, I add 3, I get x equals 3. If you notice, 3 minus 3 would equal 0. So, if I put 3 in here, 7 times 0, right, would equal 0. So the two solutions to this polynomial equation are x equals negative 4 and x equals 3. Now, a couple of things here. Solving quadratics using the factoring method. Basically, when we say quadratic, we are looking at ax squared plus bx plus c equals 0. Now, it could equal something else, but as long as you have this x squared term, you're solving a quadratic equation. And as of right now, the only way we're going to learn is the factoring method. Now, when doing this, our first step is basically to set the quadratic equal to 0. Once we set the quadratic equal to 0, then we factor the quadratic. Once it's factored, we set each factor equal to 0. And then we solve each equation. One thing I do want you to know, though, is when you have an equation, the highest exponent basically tells you the maximum number of solutions you could have. So in every quadratic, you have a choice. You could have 0, 1, or 2 solutions. Okay? And that's determined by the highest exponent. But again, you can have no solutions, 1 solution, or 2 solutions. So let's go ahead and look at this. In this problem here, if I look, this equation is already set equal to 0. So my first step is to take this polynomial and go ahead and factor it. Well, in order to factor that, I basically have to find the numbers that multiply to give me negative 8 and add up to give me negative 2. As we know, that's probably going to be negative 4 times 2. Negative 4 plus 2 makes both of these happy. So x minus 4 times x plus 2. Again, once we're done factoring, now we need to find the value of x that makes this equal 0. How do I do that? I pull that factor out, set it equal to 0, and solve. And when I do this, I get x equals 4. Then another solution is taking this factor out and setting it equal to 0. And when I solve this equation, x equals -2. So the two solutions to this quadratic equation are x equals 4 and x equals -2. Okay, that's pretty much an easy problem. Okay, the next one ends up being a quadratic, but when you look at the leading coefficient, it is not equal to 1. Therefore, it's a method of factoring we have to use is AC method. So when I look at it, I have to multiply to get AC, which gives me -30. And I have to find the numbers that add up to 1. Now remember, is this quadratic set equal to 0? Yes. Therefore, we are ready to go. So numbers that multiply to -30 add up to 1, -5 times 6, and -5 plus 6. Makes both of these happy. So remember, we break this middle term up into, so we have 3x squared. We're going to go minus 5x plus 6x minus 10. Once we do that, don't forget, we group the first two and the last two terms. What's a GCF here? Well, GCF here is x times, when I divide by x, 3x minus 5. Okay, here my GCF is 2 times, when I divide by 2, I get 3x minus 5. Now, do my insides times the outsides. And once I'm in factored form, remember, this is equal to 0. So, over here, just kind of looking back at the first example, I look at it and I say, okay, why do I have to set this equal to 0 when I know 4 minus 4 is going to be 0, so x has to be 4, and -2 plus 2 is 0, so x has to be -2. Why do we have to set them equal to 0? Well, when we look at this type of factor is not as easy to identify what the solution for x is going to be. So getting in the habit of taking these and actually setting the factors equal to 0 will help you out in the end. So I pull both factors out, set them equal to 0. First, I add 5 here. 3x equals 5. Then I'm going to go ahead and divide by 3. And x equals 5/3. Over here, subtract 2, x equals -2. And here are my two solutions. X equals 5/3 and x equals -2. Remember, when solving quadratics using the factoring method, the name of the game is factoring. That's the hardest part. The rest is easy. Hope you enjoyed the lesson, and make sure you do the practice problem.